3.6, inverse of functions. Inverse relations. A reflection of the graph of the original relation over the line y equals x. So if you think about this graphically, y equals x has a slope of 1 and a y-intercept of 0. So we start at 0. We're going to go up 1, right 1, up 1, right 1. So this is the equation y equals x. Just pretend that's perfect, okay? All right, so we're pretending this is a perfect y equals x line with a slope of 1 and a y-intercept of 0. So if I were to, let me draw something easy. Let's just do a box. All right, and I will shade this half right here, this portion, this section, okay? And I'm going to reflect this box over the y equals x line. This is not going to be perfect because I am not amazing at this, freehand anyway, but it's going to look something like that. So we are reflecting it over this y equals x line, and that's how you find the inverse function. So we can do this graphically, but we can actually even easierly do this algebraically. So algebraically, the equation of the inverse is found by switching the y and the x. And then just solving for y. The notation that we use for inverse, so let's say we have f of x as our given function. Then we have f to the -1 of x, and that means inverse. So then if I use y, the inverse of y is y to the -1. So don't think of it as like a -1 exponent. It's not what it means. It's just the notation that we use for inverse. And you'll see that on your calculator. If you look on your calculator where it says sine, cosine, and tangent, and then above it, it has sine -1, cosine -1, tangent -1. Those are the inverse functions of those trigonometric functions. Okay, so let's do an example. Example 1, y equals 3x minus 5. So the first thing I'm going to do is take my x and my y, and they're going to flip places. Oops, that's not what I wanted to write. Okay, now that they've flipped places, we are going to solve for y. So we'll add 5 to the other side. And then we're going to divide both sides by 3. So then y equals x plus 5 over 3. I'm not done. I need to write my final answer. My final answer is y to the -1, the inverse of y. That's how we read it. The inverse of y is x plus 5 over 3. And then, of course, you guys know I don't like to play Where's Waldo with the answers, so give it a nice box or make it easy for me to find. So go ahead and pause the video, try B, and then resume when you're ready to check your work. Okay, so we start by flipping the x and the y, solve for y, and then our final answer is the inverse of y is x minus 2 all divided by 4. All right, next. Inverse functions. Functions f and g are inverses of each other, provided their compositions are both x. So that means we would find f of g of x, and that needs to equal x. And then also when you flip the order, g of f of x would also be x. So if this statement is true, that means f and g are inverse functions. So let's take a look at an example. One of your test questions would be prove that these two functions really are inverses, and this is what I'm going to be looking for when I ask that question. So we need to do two problems. We're going to do f of the inverse of f and we're going to do the inverse of f of f. Okay, so two problems. All right, so f of the inverse of f. So let's do some color coding here. We'll do the first function is red. The second one we'll do as blue. Okay? So we're going to start with the first function, f. And instead of an x, we're going to leave a space so that I can put the inverse of f in there. Okay? And now we're going to simplify. So using the distributive property, 3 times 1/3 x is x. 3 times 5/3 is 5. Bring down the -5. The 5's cancel, leaving us with x. So far, so good. Okay, we got our first composition to equal x. If the second one also equals x, then they are definitely inverses. If not, then they're not inverses. So now I'm going to start with what we believe is the inverse function. 1/3 of x, but instead of x, we'll leave space. Then we'll input the f of x function. And then we're going to distribute. 1/3 times 3x is x. 1/3 times -5 is -5/3. Bring down my +5/3. -5/3 and 5/3 cancel. We're left with x, so yes, they are inverses of each other. Go ahead and pause the video, and I want you to try letter B. All right, letter B does work out. You should get down to both of them equaling x. So the first one is f of the inverse. So that would be 4 times 1/4 x minus 1/2 plus 2. Distribute and simplify. The next one would be the inverse of the regular of f of x. And that would be 1/4 times the quantity 4x plus 2 minus 1/2. Distribute. So you get x plus 1/2 minus 1/2, and that one works. Let's do some practice.